Great. So what I want to do is kind of get started a little bit with the integer set class. I've adjusted it to absolutely require the use of logical operations. I've forbidden you to use if statements in the implementation of intersect union, and I'm going to have you do set difference, and that's my favorite set operator, and complement. Right? But they're all doable, and I'll show you how that's done. They're all doable without using if statements. Very, very clean in the short run. So the idea again is grab some more pen. The idea is to implement an integer set. So we're using the mathematics of simple integers in a set. So I might have A as 3, 5, 6, 9, and B as 2, 3, 6, and 8. All right, just to remind you what this is all about, right? A union B will be the set 2, 3, 5, can't write 3 anymore. 3, 5, 6, 8, 9. You do not replicate. So 3's occurred twice and 6 occurs twice. You don't replicate them. Intersection is, in this case, 3 and 6. Gee, 3 and 6. And I would like you to implement, this is for those who like to get code off the internet, implement set difference. And that is, so in the case of A minus B, you would end up with 5 and 9, because you basically subtract out the 3 and the 6. And that turns out that A minus B is A intersect the complement of A intersect B. So set difference can be implemented as the use of intersection and complement. So by implementing A union B or A intersect B, of course, complement A would be, in this case, 0, 1, 2, 4, 7, 8, 10, 11, and all the way to 100. I'm not going to enumerate that. So it's a full complement set. So that's what I mean by complement. Yeah.
The difference is the complement of the intersection.
I'm sorry. Yeah, I need to. Yeah. Put parentheses on it. Sorry. Thank you. Now I'll just put it all there. Yep. Yeah. You do the intersection, complement that, and then do the intersection again against A. Right, so the intersection of A and B, as we know, is 3 and 6. We complement that, that gives us everything but 3 and 6. That keeps the 5 and the 9 around. That's why we do that. Okay. And it doesn't add anything to the set. All right. Trying to remember if there was anything else in terms of the actual methods to implement, those are the primary set operations. You are to do subset. Okay. So if S is 6 and 9, then A, or S is a subset of A, should report true. Okay. All right, S is a subset. I think I'm using the right notation. S is a subset. Okay. We want to be able to insert element. All right, so the idea would be A insert element, 7. All right, and so now 7 would be part of the set. If I insert 6, then it's already there, but it's no big deal. All right, and delete element is to be implemented. And those are very, very trivial operations. So, high level, abstract, this is what you're implementing. And printing, by the way, you can print, so if you say a.print, what I would like to see would be 3, 5, 6, 9. You may omit the commas, it's just annoying. All right. The book says to print 3 dashes if it's an empty set. I'm actually quite happy if you just print that as the empty set. It's like, well, yeah, isn't that what mathematicians use? Let's use it. So we'll just use the empty set. Plus, you can walk the array of booleans to see what numbers to print. And if there aren't any to print, you don't print any. You just print the open brace and the closed brace that you would have printed anyways, and therefore you're done. So far, so good. All right. Now, internally what you're doing what you're doing is creating an array of Boolean. 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. to 100. How many elements is that? 101. So remember that. So you're very easily going to have an off by 1 error here. Right? So be sure you declare your array 101 long. Okay, so it's a type Boolean. Okay, so you have true, false, 0, 1. I don't care. And I really wouldn't care if you made it an integer and just use 0 and 1s. I won't be fussy about that. So, so I'm just going to go ahead and use 0 and 1s because they are more easily distinguished than trues and falses. So for the case of A, right, the coding, the internal coding of this is like that, 0s and 1s. So 1 is in the position of the set element. So the set element itself is the index, kind of flipping the use of the index and the value. So a 0 indicates that is not a member. 0, 1, and 2 are not members. 3 is a member. 4 is not. 5 is a member. So the index is what gets printed out. So when you go to print out, walk the array, you check to see if this is already there. And by the way, checking to see if something equals true, if this element equals true is also unnecessary. You can just say if the element. So like the print the print routine, for example, it can say for int I equals 0, I less than equal 100, I plus plus, if set, we'll assume that this is the array is called set. If set sub I, then cout I. It's that easy. So if set sub I is true, print I. Print a space after that. That would be nice. Otherwise, your set elements are going to be all squished up against each other. It won't be very distinguishable. That's your print. You just make sure you print an open and close brace prior to that. So there's your print routine. Very, 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 very simple. Here's B. So B is also, when you instantiate again, you're instantiating these things. So A and B would be separate instantiations. You don't make a class that would hold two sets. That would be crazy. We don't have sets. We just want to represent the set, a single set, and then have methods that take the second set as a parameter. So B would be 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 0, 0, 0. So, okay. All right, these are trues and falses, right? So when I did intersection, okay, what we're doing is looking for the cases when both sets are ones, right? Yes, you can write that. If set is 1 and x set. So again, you may implement this. You may make the call A intersect B. Okay. So very similar to the rational solution of add, subtract, multiply, and divide. You can say A intersect B. All right. And so, ultimately what we want, of course, is the result to be, hope this lines up. This is not very good. I'm sorry about that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Basically, if you AND these things, these are Boolean values, right? You can AND them, right? So the ampersand of 0, 1, 0, 1, right? 0, 0, 0, 1. Okay. Intersection. Member of both. Okay. So you just AND them. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, and there's our 3 and 6. No if. Intersection is OR. Right? OR. Okay, kind of hard to separate zeros and ones, but I'll put little taggies on there. 0, 1, 0, 1. This is 0, 1, 1, 1. All right. Again, I'm going to switch this to intersection. All right. It's easier just to rewrite this. Intersection. All right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 or 0 is 0, 0 or 0 is 0, 0 or 1 is 1, 1 or 1 is 1, 0 or 0 is 0, 1 or 0 is 1, 1, 1, 1 or 1 is 0, 0, 1, 1. And there's my union. 2, 3, 5, 6, 8, 9. No ifs. So you implement or, you implement and, you can guess pretty easily how complement works. Use exclamation point. So 0, 1, exclamation point is 1, 0. In the set, not in the set. So you can go through and complement a set very, very easily. So yeah, each of the intersect, union, complement, you'll have a for loop, but it should just be a single assignment statement. All right. Make sense? Questions? Cool, huh? All right. I drag you through this. I want you to see this isomorphism, as a mathematician would call it. Isomorphism of sets and Boolean algebra, bit vectors. All right, and so we want to leverage that. And you can come up with fairly lean code as a result. So now again, you know, A intersect B. That's going to be implemented, right, as a void, okay, a void function, void intersect, right, and pass in set x, right, and so when you refer to the A set, you'll just say set sum I. The B set will be x dot set sum I, just to remind you, right? This set, I'm using set as the instance variable. There is only one instance variable, and it's an array, a bool of 101 elements. No other instance variables. No other instance variables. That would be inside of for loop, of course. And then you've got it done. Okay. The insert and the delete. If I want to insert 7 into A, all I have to do is just make sure there's a 1 there. If I want to add the element 6 into A, don't check to see if a 1 is already there, just put a 1 there. Don't just plop a 1. If I want to delete an element, if I want to delete 5 from A, change it to 0. If I want to delete 8 from A, put a 0. You don't have to do it. Ifs. Very few. The only if you should have is probably in a print statement. Are you printing that element or not? Is equal to, you can, that's useful. You will need to probably do an if statement in that. The other thing is, I'm not interested in a constructor that receives an array of integers. I want to create the set by the insertion, the insert element routine. So repeatedly use insert element. That's how I want to create sets. Questions? That's enlightening.